The purpose of this video is to describe how to compute a t-test using SPSS and then graphing the results using Excel. For the purposes of this example, we are going to use a subset of the CLEAR data, that's C-L-E-E-R-E, from Ohio State. This vision data set collected a number of patients from around the country, actually students in school, and we're using children that whose age ranged from 7 to 13. Having followed, this was a longitudinal study, and having followed the children, we can determine those who developed myopia and those who were still emmetropic at the end of the follow-up period. For our t-test, we're going to look at those children who at some point in time became myopic during their review and compare them with children who were emmetropic at the end of the study period. And particularly, we're going to look at, for the myopic children, we're going to consider them at 2 years prior to their onset of an official diagnosis of myopia. So, and then because our data set has has multiple records for each child, we're going to match them at age. So the children who are myopic or who are at some point will become myopic 2 years before they myopic, we'll look at 8-year-old kids and match them with emmetropes at the same age. In order to do this, we're going to split our file and use the age. So this will give us a number of t-tests, one for each age, and we're looking at years 7 to 13. So in order to do a t-test, we go to Analyze, and we compare means. And of course, kids that become myopic and kids who are always emmetropic are all different kids. So this will be an independent samples t-test. And we're just going to look at refractive error. And we have our grouping variable, myopic, and we're going to, we define those groups. 0 is emmetrope and 1 is myope. Okay, that's all there is to it, and you get a t-test. That's pretty slick, easy, and no problems to do. Notice we get for each year, 7 through 13, the dependent variable is refractive error. We get whether the child was not myopic or myopic. We get the N for the 7-year-olds. 94 were not myopic, 66 were. This is their mean refractive error. Note that the mean refractive error for the myopic children is 0.07 because this is 2 years before they were diagnosed. Hopefully all these means for those kids will be greater than 0, but you will, or greater than minus 0.5. You can see that there's differences in these means. We also get the standard deviation and the standard error. When we look at the output, you'll notice that for each age there are 2 rows of answers. And the assumption of the t-test is that the independent or the dependent variable is normally distributed. The variances are equal, and the observations are independent. Now, in order to test the assumption of equal variance, we use Levene's test, which is basically a ratio of the largest variance over the smallest, and then that's an F test with the corresponding degrees of freedom to the numerator and denominator. If it's significant, then that says we have not met our assumption of equality of variance. And you can see our variances were not equal all the way down there. So there's an adjustment that can be made in this situation, and it's basically an adjustment of the degrees of freedom. So if you use the regular normal t-test, you get 158 degrees of freedom, because for age 7, because it's 94 plus 66 minus 2, and that's 158. Now, there is a formula, which I'm not going to share with you at this time, that gives you just the degrees of freedom, makes it a little bit more conservative a test, as you can see the smaller t-value. But the t-values are so big because these differences are so great that in this case you get the same answer either way. That doesn't always happen though. So that's how you do a t-test. Now let's see how you graph it. Now I prefer to graph in Excel, so I'm going to copy my chart here, and I'm going to go to Excel, and I'm going to paste, and I like to use this paste option gives you the matrix with all the lines. This one clears it up. I just like the cleaner look of this, so I'm going to put that in there. Now what we want to do is measure the or look at our graph over the years. Now there's a couple of ways to do this, but the simplest way is to line things up. We're just going to get rid of column B. We're going to cut the sample size, and we're going to move it over to here, and then we're going to delete this. Now we have everything lined up, and we're going to highlight all of these figures. Here are the 3 columns: the age, whether or not they're myopic, and the mean refractive error. And then we go to insert a table, and we're going, or a chart, and a column chart. We're going to pick that one, and you can see what we get are the non-myopes, myopes, and so forth. At 2 years, myopes are 2 years prior to onset of myopia diagnosis. I mean, clearly they're becoming more myopic, but they haven't been diagnosed yet. They won't be diagnosed as meeting the criteria of myopia for 2 years. Now this is a rather rough graph, and so everybody has the same color, and we have to determine the differences by the x-axis labeling here. Right now the column bars are stepping over the myopic label. Let's change that. We can click on highlight our x-axis labels, and we can format the axis, go to labels, and here we have label position is next to the axis. Let's make it low, and that way the labeling goes below the axis and we can see everything okay. Might want to make it a little taller. Now another thing that we can do is, I like to do anyway, is these bars are kind of skinny, so we go to format data series again, and we just bring them down to somewhere in the neighborhood of 50%. And you can see now they're a little flatter. There are, of course, ways to make the myopes and non-myopes different colors, but that takes extra time. We're just looking right now to see what our graph kind of looks like. Gives us kind of an overview, but potentially is a publishable graph after doing a little bit more work with it. One thing we like to do is, it's very typical in graphs to show error bars, plus or minus 1 error bars. So the way you do that, you go to chart element. We're going to go to more options because the standard error there isn't really the one we want. We're going to go to custom. We're going to specify the value, and it comes up with a custom error. Well, the error bars go both ways, up and down. So the positive values, this is one standard error. We're going to do that. The negative values, that's going to be the same standard error down. We're going to do that. Say OK. And there's our standard errors. Now, these guys are so far apart, it's pretty clear that they are significantly different. Another thing you might ask is, what if let's look at the standard deviation, for example. Our standard deviations overlapping. We can do the same thing by just highlighting that or that, and OK. And you can see there is not a great deal of overlap between these two distributions. There's some, but at 2 years prior to myopia, this is a pretty robust finding that as a clinician, you can probably predict myopia pretty well. In fact, Carla Zadnik, Don Moody, and some others have a pretty good paper on predicting myopia from some of the variables that they collected. You should check that out. So, all right, that's it.